So what I want, everybody? Welcome back to Jumanji. We've done mole to gram, gram to mole. Now let's try mole to mole conversion. And these depend on your chemical equation being balanced. This is already balanced. But first, let's see if we can read and understand what we're looking at. We can go on to the question. And all this is saying is that when 5 moles of carbon gets together with 2 moles of sulfur dioxide and heated, it produces 1 mole of carbon disulfide and 4 moles of carbon monoxide. And the question says, how many moles of carbon would it take to react with a half a mole of sulfur dioxide instead of 2 moles, right? So carbon and sulfur dioxide are our compound, our element and compound of interest here, right? We can put this first in conversion factor form to make it easier. And your conversion factor form says 2 moles of SO2 is equal to 5 moles of carbon. We put that conversion factor into conversion ratio form, and this just shows that what's on the top of one side of your equation must then be on the bottom of the other side of your equation, right? So you can cancel your units when the time comes. And I change the equal to multiplication sign here, it doesn't really matter. Now we move on to what we're given in your question. You're given half a mole, 3 significant figures, of SO2, sulfur dioxide, right? Remember, what's on the top of this side must then be on the bottom of this side of your equation. You can remove any side of this you like, and we're working with just one side now. SO2 is on the top, so 2 moles of SO2 must then be on the bottom, leaving 5 moles of carbon on top. Moles of SO2 will cancel. You multiply half by 5, you end up with 2.5. Divide that by your 2 here, and you end up with 1.25 moles of carbon is needed to react with half a mole of SO2. It is still in 3 significant